Imagine a night like any other. The sky is clear and the stars are twinkling brightly. You find yourself gazing up, lost in the vastness of the cosmos. You look up at Orion, the hunter, but something is different. Betelgeuse, his shoulder, is gone. This star, a familiar beacon in the night sky, has vanished. In its place, a light so brilliant it outshines everything, visible even in daylight. This new light is not just a star, it's the final, spectacular act of Betelgeuse. This isn't science fiction. This is what happens when a star dies. A supernova explosion, a cosmic event of unimaginable power and beauty. Thanks to our technology, we witnessed it. Our telescopes and satellites captured every moment, providing us with a front-row seat to this celestial drama. The universe is ancient, and its grandest events unfold over eons. Stars are born, live, and die. Each star's life is a chapter in the story of the cosmos. Most fade quietly, but the biggest stars go out in a supernova, a cosmic spectacle. These explosions are rare, but when they happen, they are unforgettable. For centuries we only saw the aftermath, like the Crab Nebula, never the beginning. We could only imagine the moment of explosion. If NASA hadn't captured Betelgeuse's explosion, it would have become a modern myth, debated and doubted. The data we collected turned speculation into knowledge. Was it a military experiment, an illusion? Without concrete evidence, the truth would have been lost in a sea of theories and conjecture. Without data, the truth would be lost in speculation. We would be left with more questions than answers, and the event would fade into obscurity. But we did see it. Our telescopes, both in space and on the ground, were ready. They captured the event in stunning detail, providing us with invaluable data. When Betelgeuse ended its life, we had a front-row seat. It was a moment of awe and wonder shared by people all over the world. The light from its final moment traveled centuries to reach us, and we were prepared. We had the technology and the knowledge to understand what we were seeing. We captured, measured, and understood it. The data we collected will help us understand the life cycles of stars and the evolution of the universe. Because of that, a star's death became a moment of scientific enlightenment, a shared experience connecting us all to the cosmos. It was a reminder of our place in the universe. The universe gave us a show, and for once humanity was ready to watch. We were united in our wonder and curiosity. We witnessed the death of a star, and it changed our place in the universe. It was a moment that will be remembered for generations to come. Before its end, Betelgeuse was more than a dot of light. It was a giant, a true colossus among the stars, dominating the night sky with its presence and mystery. In Orion's shoulder it glowed red, a supergiant among stars. Its fiery hue made it one of the most recognizable stars in the sky, a beacon for stargazers and astronomers alike. If Betelgeuse replaced our sun, it would engulf Mercury, Venus, Earth, Mars, maybe even Jupiter. Its vastness is almost impossible to comprehend. Its outer layers would stretch far beyond the orbits of our inner planets, swallowing them whole. It was close, just 650 light-years away, our cosmic neighbor. In the grand scale of the universe, Betelgeuse sits practically next door, a reminder of how vast yet interconnected our galaxy truly is. We could see its surface as a disk, not just a point. Few stars are close or large enough for us to resolve their surfaces, but Betelgeuse's immense size made it possible to glimpse its turbulent, ever-changing face. We watched it pulse, dim, and brighten, the great dimming. This dramatic change in brightness captured the world's attention, sparking speculation about its fate and the mysteries of stellar life cycles. We knew it was old, nearing its end, but not when the finale would come. Astronomers watched, waiting for the moment when Betelgeuse might explode in a spectacular supernova, lighting up our skies. Betelgeuse was a factory for life's elements, carbon, oxygen, nitrogen, cooked in its core. Through nuclear fusion, it forged the very building blocks that make life possible on Earth and throughout the cosmos. The iron in your blood, the calcium in your bones, forged in a star like Betelgeuse. Every atom heavier than hydrogen and helium was born in the heart of a star, scattered across the universe by ancient explosions. Its red color revealed its age and size, a cooler, swollen ember nearing its last act. The deep crimson glow told us it was running out of fuel, expanding and cooling as it approached its final transformation. It had burned through its fuel, a ticking clock in the sky. Each pulse and flicker was a countdown, a cosmic timer marking the end of an era for this ancient star. Even stars, the universe's powerhouses, are not eternal. Their lives, though measured in millions or billions of years, eventually come to a close, leaving behind new beginnings for the cosmos. Every time we looked at Betelgeuse, we saw a promise of cosmic fireworks. Its impending supernova is a reminder that the universe is always changing, always renewing itself in spectacular ways. Its story is our story, stardust watching the stars. We are connected to Betelgeuse, and to all the stars, by the very atoms in our bodies and the curiosity in our minds. We watched, knowing we were witnessing the end of a giant, a cosmic drama unfolding above us, reminding us of our place in the universe and the incredible journey of the stars. What is a supernova? It's a question that has fascinated astronomers and stargazers for centuries. These cosmic events are among the most powerful and awe-inspiring phenomena in the universe, lighting up the darkness of space with unimaginable energy. It's the universe's most spectacular death, a final brilliant act in the life of a massive star, so intense that it can briefly outshine an entire galaxy. A massive star's life is a constant battle, gravity pulling inward, trying to crush the star, while nuclear fusion pushes outward, creating a delicate balance that keeps the star stable. For millions, sometimes even billions of years, this balance allows the star to shine steadily, radiating light and heat across the cosmos. But a giant like Betelgeuse burns through its fuel at a staggering rate, living fast and dying young compared to smaller stars like our Sun. It fuses hydrogen into helium, then helium into heavier elements, carbon, oxygen, and beyond. Each stage happening faster as the fuel runs out and the core grows hotter and denser. When it finally creates iron in its core, the process grinds to a halt. Fusion can no longer release energy, and the star's internal struggle ends. Gravity wins. The core collapses in a fraction of a second, while the outer layers crash inward at a quarter the speed of light, creating a cataclysmic implosion. The core is crushed to incredible densities, then rebounds violently. A shockwave rips through the star, tearing it apart in a titanic explosion. This is the supernova, a single star outshining its entire galaxy, releasing more energy in a few seconds than our Sun will emit in its entire lifetime. The explosion flings heavy elements like gold, silver, and uranium into space, seeding the cosmos with the raw materials for new stars, planets, and even life itself. It's both an ending and a beginning. The death of a star becomes the birth of new worlds, as the remnants drift through space and gather into nebulae. The star is gone, but its ashes become the building blocks of the cosmos, forming the next generation of stars and planets. Supernovae are cosmic recycling at its most dramatic. From death comes creation, and from destruction, new possibilities arise. The universe's story is written in these explosions, each supernova a chapter in the ongoing saga of creation, destruction, and rebirth. Imagine the moment Betelgeuse's light reached us. Where a red star once shone, a new blinding light appeared, brighter than anything but the moon. It didn't twinkle, it glared, casting shadows at night. People everywhere saw it, a new diamond in the sky. The supernova was visible even in daylight, a second sun haunting the blue. For weeks we had two suns, one alive, one a ghost. The world reacted with awe, wonder, and a touch of fear. News spread instantly. Everyone was watching. Scientists explained it was distant, beautiful, and safe. The event became a global science lesson, uniting us in curiosity. As the supernova faded, its memory burned into our minds. Orion was forever changed, a warrior missing a shoulder. The universe proved itself dynamic, alive, and ever-changing. That night, our perspective on the cosmos changed forever. Observing Betelgeuse's supernova wasn't easy. Its light took 650 years to reach us. We saw the past. We can't predict exactly when a star's light will arrive. Earth's atmosphere blurs and distorts starlight, making observation tricky. That's why we build observatories on mountaintops and launch telescopes into space. Supernovae emit energy across the spectrum: gamma rays, X-rays, infrared. Our atmosphere blocks most of this, so space telescopes are essential. Without them, we'd miss most of the story. A supernova's peak brightness lasts weeks. Miss it, and the data is gone. It takes a global network of observatories ready and coordinated. Decades of planning and technology made this observation possible. Without preparation, Betelgeuse's death would have been seen, but not understood. Science turned a fleeting light into lasting knowledge. When Betelgeuse's light arrived, NASA was ready. A fleet of telescopes, Hubble, Webb, Chandra, captured every wavelength. Hubble saw the expanding cloud, Webb peered through dust, Chandra caught the high-energy blast. Each telescope revealed a different layer of the story. Together they gave us a complete three-dimensional view. We measured speed, temperature, and the elements forged in the explosion. NASA's data turned spectacle into science, shared instantly with the world. Scientists everywhere collaborated, publishing discoveries at record speed. The proof was undeniable: a star's death, captured and understood by all. But what if we hadn't captured the proof? The light would still appear, but confusion would reign. Without data, speculation and fear would fill the void. Myths, conspiracies, and wild theories would spread. Scientists could guess, but without evidence, their voices would be lost in the noise. The event would become a modern legend debated for decades. The truth, a supernova, would be buried under rumor. The chance to learn and be inspired would be lost. Science needs evidence to unite us in understanding. Without it, even the brightest event can become a mystery. The Betelgeuse supernova proved that seeing is believing, when seeing means measuring, recording, and understanding. Our eyes see only a sliver of the universe, technology reveals the rest. NASA's images and data ended debate. There was the proof. We saw shockwaves, chemical fingerprints, even neutrinos from the collapsing core. Every instrument told the same story: a star's death, written in physics. This event changed our relationship with the cosmos. The universe became knowable, its laws the same everywhere. We are stardust, forged in explosions like this. That's why we explore, to anchor our understanding in reality. Observation is the bedrock of science, keeping us honest. It protects us from superstition and dogma. The power of seeing Betelgeuse's supernova was in knowing it was real. It gave us confidence in our ability to comprehend the universe. We saw, we understood, and we belonged. The story of Betelgeuse isn't an ending, it's a beginning. For every answer, new questions arise. What other stars are nearing their end? What mysteries remain? The universe teems with puzzles: dark matter, dark energy, the search for life. The elements of life are everywhere. Is life itself common too? Are we alone? Or are other minds looking up at their skies wondering about us? We must keep watching, building bigger telescopes, sending probes farther. The universe is a laboratory, its experiments ongoing. The next great discovery is out there, another dying star, or a signal from another world. We just have to be ready and keep looking up.